At 3:07 p.m. UTC on February 24, 2008, YouTube vanishes from the global routing table. Across Europe, videos fail to load. In Asia, pages return blank screens. In the United States, browsers endlessly spin until connections finally time out. This global failure is simultaneous and total. To the engineers monitoring the sudden drop in outbound bandwidth, the situation is a complete anomaly. There is no cyberattack on the grid and no physical server fire. Traffic is simply moving into a void. This flowchart illustrates exactly how the internet routes traffic using the Border Gateway Protocol, or BGP. It operates as the internet's global routing system. Every single packet of data relies on this sequence. It checks the destination IP, matches a specific routing prefix, follows an established autonomous system path, and finally reaches delivery. The design assumes a baseline of honesty. BGP expects every autonomous system, whether it's a small regional provider or a massive multinational carrier, to broadcast unverified routes to its neighbors. There is no built-in mechanism to check if a route is legitimate. In 2008, YouTube's architecture was highly centralized. They had not yet deployed modern distributed content delivery networks or unicast load balancing. They relied almost entirely on single-homed IP blocks, pointing directly back to a few centralized serving clusters. This diagram shows the specific IP routing prefixes keeping the entire platform alive. If you wanted to reach a video streaming node or a metadata database, you had to pass through either 208.65.153.0/24 or 208.65.152.0/22. Because the platform lacked decentralized distribution, those unverified centralized IP routes were the only path in. Whoever controlled those two prefixes on the BGP map effectively controlled the entirety of YouTube. The catalyst occurs on February 24, when Pakistan's government orders its internet service providers to block a specific controversial video on YouTube. To comply with the order, Pakistan Telecom, designated as AS17557, creates a BGP route specifically designed to capture every domestic request for YouTube and drop them instantly and completely into a digital black hole. The internet operates on a strict rule: more specific routes win. YouTube broadcasted its location using a broad /22 subnet mask. By announcing a narrower /24 subnet mask, Pakistan Telecom created a route that the internet's logic automatically prioritizes. By utilizing that /24 subnet, Pakistan engineered a mathematical instruction formatted to override YouTube's default route. It was designed to keep Pakistani traffic inside the country, but it was highly volatile if it ever escaped those domestic borders. The containment fails almost immediately. Pakistan Telecom accidentally broadcasts this more specific, localized black hole route outward to its upstream provider, PCCW. PCCW receives the route and commits a critical error. Instead of filtering out the suspicious domestic block, they accept the announcement at face value. Because the /24 route is mathematically more specific, global routing tables accept it as the new optimal path to YouTube. PCCW propagates it to Tier 1 carriers. Tier 1 carriers propagate it to regional ISPs, and within minutes, global routes shift. The entire world now updates its maps. A localized attempt at censorship slipped through a single unmonitored connection. Using BGP's logic, it unintentionally weaponized the infrastructure of global telecom carriers against one of the largest bandwidth consumers on Earth. The physical reality of the hijack hits immediately. Packets from London, from New York, and from Sydney, meant for Google's massive server farms, are suddenly hurled blindly into a telecom router in Pakistan. With zero capacity to handle the petabytes of global video traffic, the hardware is instantly overwhelmed. The traffic drops dead. Back in California, YouTube's network engineers watch their inbound traffic flatline. Running traces on the network, they see the AS paths redirecting away from their clusters and pointing directly to AS17557 in Pakistan. Looking at this terminal view, you can see YouTube's counterattack. Engineers use the exact same protocol logic. They announce /25 prefixes. Because a /25 is mathematically even more specific than Pakistan's /24, it forces global carriers to abandon the rogue route. Resolving the crisis requires no hardware repairs and no tracing of malicious hackers. It is mathematical warfare fought by shifting numbers across global routing tables. Carriers essentially implement emergency filters to block the rogue announcement from Pakistan Telecom. Global AS paths slowly revert to YouTube's legitimate servers, and traffic flows back to the platform. The outage exposed a systemic vulnerability in the Internet's design, proving that a global network cannot depend on the unverified honesty of its members. Google and YouTube immediately accelerated an architectural pivot. They abandoned highly centralized, single-homed IP setups. They deployed global CDN caches, implemented unicast frontends, and pushed for the industry-wide adoption of cryptographic route origin validation, known as RPKI. The Pakistan incident served as a stress test. It forced mission-critical networks to transition from systems of assumption into systems of strict cryptographic verification. The 2008 BGP incident proved that the Internet's foundational routing protocol was built on a dangerously fragile web of blind trust. It took the sudden disappearance of the world's largest video platform to force global infrastructure to finally prioritize cryptographic verification over protocol assumptions. Thanks for joining Database History. The Internet is a network of networks, and one single mistake can break them all.